Hey everybody, so today we're going to be discussing fractional exponents. So in yesterday's video we discussed taking the square root of a value, right? And we already knew that this came down to 2. The way we broke this down is we said that this was just the square root of 2 times 2, okay? Which is the same thing as the square root of 2 squared. And I had mentioned that these square roots and the squares simplify out, leaving us with 2, alright? Okay, well, why does that work? So what I want to make sure that we get into today is a certain property that we know. We can say that the square root of x is the same thing as taking x to the 1/2. This is one of your main key points for today, and we're going to be exploring this. Okay, so again, the square root of a value is the same thing as taking that value to the 1/2. Let's go ahead and prove this. Okay, and we'll use this same example. If we say we're taking the square root of 4, okay, and we said that that was the square root of 2 squared, and we just said taking the square root of something is the same thing as taking it to the power of 1/2, well then that means that we would get 2 squared. All this here would be to the power of 1/2. So we've got 2 to the power of 2, all of that to the power of 1/2. Well, how do we work this out here? Okay, so we covered in the past, we covered the power rule. Okay, and that power rule said that when we had m to the n to some type of q, okay, sorry about that, we'll say q, not 9, this is a q here. This is the same thing as m to the n times q. Okay, so in other words, what we're going to do with these two values is we're going to be multiplying these two values. So if we said 2 times 1/2, that's the same thing as 2 over 2, which is equal to 1. So we'd be left with 2 to the 1, which means that we would have 2. And that works out here. Let's try that one more time. Let's see, we were going to take the square root of 16. Okay, so we would say that this was 4 squared. But if we're taking the square root of this value, we know that we're raising this 4 squared to the 1/2. Using the power rule here, we know we would be doing 2 times 1/2 equals 1. So these would simplify out. They don't cancel. It doesn't become 0. It becomes a 1. We have 4 to the 1. What does that look as far as cubes and cube roots? So if we say we were going to take the cube root of 8. So we discussed yesterday that the cube root of 8 looked like this. We said that we could break down this 8 as the 2 times 2 times 2, because 2 times 2 is 4, times 2 is 8. In other words, we could rewrite this as 2 cubed. Well, we'd be getting here, we'd say 2 cubed, and in this case, what do we do with this cube root? Well, that means here, if we're taking the cube root of a value, that's equivalent to taking it to the power of 1/3. You need to look at this index number here, and this is what we're going to be creating as our fraction. So when we had square roots, we knew the index value was 2, so we took it to the 1/2. With cube roots, we know it's 3, so we'd be taking it to the 1/3 power. So what we're going to have here is we're going to take this to the 1/3. Using the power rule, we know that we're going to multiply these two values up here. We would say 3 times 1/3 is equal to 3 over 3, which is equal to 1. So we're left with 2 to the 1, which is just equal to 2. And that's correct. Okay, let's do one more. Let's do the cube root of 64. Okay, So the cube root is 64. We need to think of three numbers multiplied that give us 64, and we're going to prove this here. So we could say the cube root of 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. Cool. So we would say here that we would take 4 to the third power. Well, this would be 4 to the third to the 1/3. Quick maths here now. We can say 3 times 1/3 is 1. So we'd be left to the 4 equals 4. And that's how these simplify out. Okay, very cool. Let's say, and we're going to take this one step further. Let's say we get some type of fraction that doesn't work out as well as we'd like it. Well, we're going to do something. We're going to split this up into parts. So let's say I present 4 to the 3/2. Oh, so this is different, and this is what we're going to be exploring today. What do we do when we have fractions like this that aren't like 1/2 or 1/3? Okay, we're going to be undoing that power rule. What do I mean by that? Well, let's think of two numbers that I can split this up. We know that we like having x to the 1/2 or x to the 1/3. So how do we split up? I want you guys to pause the video here, and I want you guys to think about this for a little bit. Okay. Well, if I'm going to just split this up here, what we're able to do is we're able to say that 3/2 is the same thing as 1/2 times 3. Right? If we were to multiply this across, 1 times 3 is 3, 2 times 1 is 2. So this is what I'm looking at here. I really want this 1/2 times 3. So what I'm able to say here is I can say 4 to the 1/2 times 3. So we split this up. Now, we don't want to multiply this back because we get stuck back in this point here. We need to apply a reverse power. In other words, when we take this here, you guys already know that when we said we had m to the n times q was the same thing as m to the n q. Well, in this case, instead of having m n times q, we can split these up and go in this direction. So we can stack these exponents. So we'd have 4 to the 1/2, and we can raise all this to the third power. I know it's confusing. We'll do a couple more of these together. Okay, so we have the situation here. Well, look at here. We have 4 to the 1/2. Well, we already know if we have some value to the 1/2, that's just the square root of that value. So we're really just saying the square root of 4 cubed. Well, what's the square root of 4? You already know that's 2 cubed. Well, that's just 2 times 2 times 2 equals 8. So we can say 4 to the 3/2 is equal to 8. Let that sink in for a little bit, and we'll do another one together. Let's do 9 to the 3/2. Well, we can say this again. We can say that this is 9 to the 1/2 times 3. Broke up this fraction. So we know that we can do 9 to the 1/2 to the third power. Well, 9 to the 1/2, okay, that's just the square root of 9. We know the square root of 9 is 3. And we can't forget our cube here. Well, what does that mean? I've got 3 times 3 times 3. 3 times 3 is 9 times 3 is 27. So we can say that 9 to the 3/2 equals 27. Cool. What if we... Alright guys, so let's go ahead and look at the example of 8 to the 2/3 power. How would we break this down? Well, if we had it The other way you guys already knew we would break this down as multiples of the numerator and multiples of the denominator, right? So we could say this is 8 to the 1/3 power times 2. Okay, so because we know that 1 times 2 is 2, divided by 3 is 2/3. So what we can do is, using that reverse power rule there, we could say we'd have 8 to the 1/3, all this going to the power of 2. Well, 8 to the 1/3, that's the same thing as saying the cube root of 8 squared. Well, the cube root of 8, you guys have already solved, that's going to be 2 cubed. So you already know that these simplify out here, so you're left with 2. Can't forget that we're squaring that from here. And so we're left with 4. Well, let's do one more example. Let's go ahead and do 64 to the 2/3. Well, we can break this down as 64 to the 1/3 times 2. Okay, assume rules is the last question there. We would say that this would be 64 to the 1/3 squared. Well, what is the cube root? So what we're asking here of 64. This cube root of 64, you guys would have already seen from previous videos that that's going to be 4. So we have 4 squared, which is going to give us 16. So we can say that 64 to the 2/3 is equal to 16. Very cool. Alright guys, well, that's going to conclude it for this video here. Please make sure that you complete the appropriate activity, which will be fractional exponents for April 7th on your team's workbook. Alright guys, go ahead and find out the assignments. We'll see you all tomorrow.